So along with exponentials comes logarithms, so we're only going to look at the natural log for now, but we need to find the derivative of the natural log. So we're trying to find the derivative of the natural log of x. So to find the derivative of the natural log of x, let's think about what the natural log of x is. Natural log of x is the inverse of e to the x. So what that means is that e to the natural log of x is just x. Right? These two are inverses of each other, so that's what it should mean. Which means that the derivative of the left-hand side here should be the derivative of x. Okay? So, on this right-hand side, what's the derivative of x? That's just 1. We know how to find that one. What's the derivative of e to the natural log of x? Well, using your chain rule, it's going to be e to the natural log of x times the derivative of natural log of x. And this is what we're trying to look for. So I'm going to divide both sides. So I'll get the derivative of natural log of x is 1 divided by e to the natural log of x. And what was e to the natural log of x? That was just x. So this is the big kind of takeaway from all of this, is that the derivative of the natural log of x is 1 over x. So that's the derivative rule for logarithms, for natural log for right now, is that the derivative of the natural log is 1 over x. So let's do a few examples on how to implement this. This is just another kind of rule that we can do with the chain rule and the product rule and the quotient rule. So let's let f of x be natural log of x plus 3. Let's find f prime of x. So this is a sum. That just means we're going to take the derivative of the first plus the derivative of the second. So the derivative of natural log of x, we just did that. That's 1 over x. And then the derivative of 3 is 0, so adding 0 doesn't do anything, so there's your f prime. Okay, this time let's let f of x be the natural log of x squared minus 3x plus 1. And let's find f prime of x. So to find f prime of x, I need to take the derivative. Well, this is natural log of something, but that something is not just x. So this means I have a chain. Whenever this isn't just x, I got a chain. What is my first function? That's going to be the x squared minus 3x plus 1. And what's my second function? Natural log of x. So now start with the bottom. What's the derivative of natural log of x? That's 1 over x, but I don't write the x. Remember, I write everything that's above this. So x squared minus 3x plus 1. Now what's the derivative of x squared minus 3x plus 1? That would be 2x minus 3. You could write this as a fraction. So 2x minus 3 over x squared minus 3x plus 1. So there's your derivative. So we had to use the chain rule here, which we always use chain rule, just using the fact that the derivative of natural log is 1 over x, and then multiplying by the derivative of the first function. How about, let's let f of x be x cubed over natural log of 5x minus 3. Let's find f prime of x. So I have x cubed divided by something, so this is a quotient, so I'm going to need a u and a v. U is always the numerator, v is always the denominator. Now I just got to find u prime and v prime. So u prime, the derivative of x cubed is just 3x squared. And now what about the derivative of 5x minus 3? Well, that's a chain again. First function is 5x minus 3, second function, natural log of x. So now the derivative of natural log of x is 1 over x, so it'll be 1 over 5x minus 3. And then times the derivative of 5x minus 3, so times 5. Now that I have my u, v, u prime, and v prime, Let's find the derivative. So it'll be u prime v minus u v prime all over v squared. So I'm still using the quotient rule, the product rule, the chain rule, all the same way that I was before. I just have more functions to work with. So let's look at something we haven't necessarily seen. Let's let f of x be x to the x, and let's find f prime of x. Okay, so we're going to kind of use a trick here because this isn't a base to some power of x. This is having an exponent in the base and in the power. So generally when you see something like this, you want to rewrite it in terms of exponentials. So instead of saying my function is x to the x, I'm going to use the fact that e to the natural log of something is just that something. So all I did was write e to the natural log of x to the x, because these are inverses. And then I can bring this exponent out to the front. So it'll be e to the x times natural log of x. Okay, now this is a function we can find the derivative of. So we rewrote it so that we can find the derivative. So this is e to something that's not just an x. So that's a chain. First function is x times natural log of x. Second function is e to the x. So, derivative of e to the x is e to the x. In this case, though, we want e to the x times natural log of x. Now I gotta find the derivative of x times natural log of x. Well, that's a product. So I'm going to find my u, v, my u prime, and my v prime. And I'm going to plug it into my product rule. So let's see, u prime v will be natural log of x. U v prime, x times 1 over x is just 1. So here is my derivative. Now I could simplify this just a little bit. E to the x natural log of x was x to the x. You could rewrite it this way. You don't necessarily have to, but there's your derivative. So all we did was rewrite this, and you can do this whenever you have x in the base and the exponent, rewrite it in terms of e to the natural log, and then bring down your exponent. And that'll give you a chain that you can actually work with. So the derivative of x to the x we found was x to the x times natural log of x plus 1.